Welcome everyone to the Data Spaces technical training. SEAMWARE, Seamless Middleware Technologies, with the support of FIWARE Foundation and the collaboration of Gaia-X Spain, is hosting this 3-day training on FIWARE technologies for data spaces, starting with the FIWARE vision and architecture for trusted data services transactions. We will progressively dive into the FIWARE Dataspace Components and the FIWARE Data Space Connector, exploring how they enable the creation of interoperable, secure, and business-ready data spaces. And through practical demonstrations and interactive sessions, you will gain first-hand experience with FIWARE technologies and their unique value proposition.
Okay, then yeah, we can start. Welcome to the first session of this series of webinars that we are organizing together with the FIWARE Foundation. My name is Stefan Wiedemann. I'm a senior software engineer at SEAMWARE and a member of the FIWARE Technical Steering Committee. And as the first session, we will start with the foundations and technical architecture of data space, of a FIWARE data space. Because obviously it's important to understand how we envision a data space itself. Data spaces are a huge topic right now, and there are different definitions and visions about data spaces out there. So I want to start really with the vision of FIWARE and the FIWARE ecosystem about data spaces. So for us, data spaces are governed ecosystems enabling participants to sustainably create value by interacting in a trusted, sovereign, and agile manner. That could go as let's say, one-line definition of a data space for us. Now we obviously have to put some meaning into that sentence. So what does sustainable creation of value mean for us? For a participant of a data space, it's important to really have an incentive to be a part of a data space, to make a data space essentially something where people want to participate and organizations want to participate. They need to have an incentive. It's not just I have data, I want to share it. They really need something why they should invest them and what they should get on what they can get back from being part of the data space. And this value creation inside the data space should be somewhat fair and balanced. So every participant of the data space should benefit from being part of the data space, be it as a data provider or be it as a data consumer, or obviously be it both of it. Trust is a very important point of a data space. It's something that you will hear a lot about today in this presentation. What does trust mean? Obviously, participants can interact with each other with some confidence. So they know whom they are interacting with. They apply to the same rules with each other, and therefore can have some trust in their interaction with each other by getting the data, by offering the data, by using the data. Sovereignty is another important point for us in a data space. That means participants can really exercise control over their data and also about their usage itself. So not only that the organization itself can do something in the data space, but it can also define who is allowed to act for them, who is allowed to consume the data for this organization, for this participant of the data space, and also who is allowed to offer it or to reuse the data and what way. That's something that the participant itself should be able to control, not a data space, global entity, or somebody that offering the data for them, but every participant itself should have this power. And Agile, obviously, it should be easy for someone to become a participant. It should be easy for a participant to offer and consume services in a data space. It should essentially be some kind of plug-and-play mechanism to become part of a data space and to make use of the data space and the data in the data space itself. Because if let's say the hurdle is too big to become part of the data space and to use it as part of your application or your daily business, then organizations or people don't want to become part of the data space. So that's essentially the core of our vision for data spaces. Now, to extend that, what we also see is that in our vision, we need to, let's say, widen the idea of a data space. So when we talk about data spaces, obviously the core is data. But for us, data is not just, let's say, plain CSV file that somebody can share, but it's something much more powerful. If we are only about to share plain data, we're essentially rebuilding something that we call open data with steroids. So if you're aware of where FIWARE is coming from, we worked with open data and with sharing data for years already. And open data itself does, let's say, somewhat fail due to the fact that we only have that we always only talk about plain data. But if we're talking about real-world business cases and real-world data spaces, then organizations don't want to publish plain data all the time. And organizations also don't want to just consume plain data. But they should also be enabled to provide actual applications. They should be able to offer services for accessing, processing, visualizing, and interpreting data. So we don't want to have data space where you can just share your plain data stream, but you should also be able to share your, let's say, value-adding application to the data space. Because most of the time, the data provider is also somebody that already has some insight into the data itself. For example, if you have a company collecting air quality data, this company usually is also the company that knows how to process air quality data or to build a meaningful dashboard. And we want that in a data space, this company can then also share this service or this application to the other participants of the data space. They can do this through APIs, but they can also share this through graphical user interfaces, directly serving end users inside the data space. So a participant then can not only consume the plain data and has to do all the visualization and processing and so on themselves, but they can actually give their employees, their users and so on, direct access to an application that already does that for them. Which brings us to the next point. So for us in data spaces, it's not just about organizations consuming offering data. It's about also enabling users or technical services like AI agents, like simple services, or like IoT agents that can act for the service, for the organization and consume applications. So in a FIWARE data space, natural persons are essentially first-class citizens. So you have natural persons interact in a data space. You have devices or software agents that can interact in a data space, and they can do this with their own identity. They get empowered by the organization to do so, but they can act even independently from the organization, but still under the whole governance framework of the data space. You will see how this is implemented in essentially the second part of today's sessions, where I will talk a little more about the IAM concept. But it's a very important point for us in data space. So we don't talk just about organizations interacting with each other, but we always have also the, let's say, actual persons or services that carrying out that interaction in mind. Yeah, so here are some more examples of how this vision can really help us to broaden the idea of a data space. Yeah, so let's say I already had the example with the air quality data, but you could also say we have a city that wants to offer routes to the visitors. They don't have to just offer them the plain data of, let's say, the coordinates. They can already provide them a map that displays it. And another part of the data space can just reuse this application instead of building their own visualization on top of that again. So that's part of our idea of a data space in FIWARE. Now, getting further about some key concepts in the data space. As already mentioned, we're not just about data, so we need to have some concepts for products, services, and resources. In the FIWARE data space, a participant can always play the role of a provider or a consumer, or even both of them, of products. Depending on the current, on the concrete interaction, a participant always is, for this concrete interaction, either the provider of the data, of the product, of the service, etc., or the consumer of it. Now, what is a product? A product usually is a combination of a service and resources. The service itself provides access to, and also the processing or the interpretation, visualization of the data. Obviously, it's not necessarily always an interpretation or visualization. So FIWARE data spaces can also be used to share plain data. So you can also have a raw data stream or an, let's say, an FTP server offering CSV files or whatever. But you can do the, let's say, use the much more powerful concept of a service that provides access to this data. Resources are then the more concrete, not necessarily physical, but it could also be computational resources that are required for the execution of those services. Product itself, as mentioned, may be pretty simple or something sophisticated. So a product can just bring access to the data set, or we can talk about a product like the air quality monitoring system, which compromises of a number of systems, of services. So you could have some backend REST services. You could have a web portal in front of them, which gives you access to the data, which helps you to process data, maybe to include some, let's say, predictions into your own system. Imagine, for example, IoT devices that should act on change of air quality. You can get the air quality from a data provider inside your data space, and then consume it with your own IoT device that then acts on those changes. And it obviously could also be used for visualization or interpretation. So you have some data analyst going to the dashboard and checking the data and, let's say, manually analyzing this data. Now, a product is provisioned and activated for giving consumers inside the data space, and that happens through contract negotiation, essentially. So the consumer or the customer, which in this case obviously is also the consumer of the data, acquires the right to use this data. This might require provision and activation in some cases, which, depending on the complexity of the product, can happen directly, but it also can, let's say, take some days. So if you, let's say, have a product that requires the deployment of some hardware resources, again, like, for example, some sensors, then this may take days. Or you have just something that gives you access to existing data, then obviously it can happen instantly. So depending on the product, the provisioning and activation may take time or may not. Yeah. So this is very much dependent on the type of the product, how you can activate and provision a service inside your data space. Another key concept that is very important for us is how we handle users and decentralized users and identity and access management. More concretely here, decentralized identity and access management. As I already told, we're not only talking about organizations interacting with each others, but in the FIWARE data space, we are also treating the concrete users and services that act inside the data space as, let's say, part of the data space. And to make that possible, we need something like identity and access management that helps us to manage that. And since we want to have our participants have full sovereignty about their users, about their services, and so on, we need something, let's say, more advanced than the existing identity and access management systems, where you, let's say, register your users at the data provider side, and then they get access. We want to have something where the user is still under control of its own organization. Therefore, we are using decentralized identity access management. I will go into the real details of the identity access management in the second part of the presentation, but just to give some initial information, what this is about. So we have users in our data space, as I already mentioned, that can consume products offered by other participants. Those users can be natural persons like employees or customers of an organization. It could be devices, it could be software agents, it could be AI agents. All of them might consume data or use services offered by a data provider, and all of them need to be managed by the organization itself. So the organization that acquired the rights to use those applications, essentially being a consumer organization in that exchange, needs the ability to manage its users, to give them the power and the permission to actually use the other data, the data provider's data on behalf of the organization. We're essentially, or we mostly do this by using the concepts of decentralized identifiers and verifiable credentials. Decentralized identifiers and verifiable credentials are two concepts that are getting more and more, let's say, state of the art currently, but they are not well known by all people yet. But they are the central solutions for decentralized identity and access management. Decentralized identifiers and verifiable credentials will be used to describe the organizations and the users. Yeah? The model itself is very similar to what we already have in the physical world. So a verifiable credential can be imagined as something that is very similar to the physical cards that we have in our wallet. So somebody gave us this card, and then we can use this card independently from the organization that have provided us with that card to do some stuff, to use the permissions that are bound to that card. Let's say I get an employee card from my employer, then I can use this employee card more or less independently to open the door or to identify myself inside the rooms. This enables the decentralization that we want to have in our data space. Yeah, the organization also gives this card to an employee, and then the employee or the user or whatever the surface, the device or software agent or whoever got this credential can now use it to identify and authenticate itself with another organization. This also has some features for supporting privacy. It also brings some additional security layers that I will talk about later that we can use to make actually our vision of data space reality. Decentralized identifier is another part of that, which is, let's say, a way to identify or to give a resolvable identifier to organizations or users that they can be used and where we can bind the credentials to. Yeah, as I said, more to that details later. Verifiable credential itself can be used to provide not only attestations about the users, but we can also use them to provide to attest characteristics of a product that is offered by a provider. So if I offer a product inside my data space, we already talked about the trust that we need in this data space. So if I offer a product, my consumer might want to have the guarantees that this product fulfills certain characteristics. So if I want to offer, for example, a credential that is compliant with regulations like GDPR, or that has low carbon emissions, or it has technical compliance with certain standardized interfaces, then I can certify this in a verifiable credential. This verifiable credential can come from, let's say, trusted third party. So not the provider itself will guarantee that my product has this, let's say, GDPR compliance, but it can provide a verifiable credential where you have a third party, like in case of GDPR or some public service that certifies that the product actually complies with GDPR. That brings us an additional level of trust into the data space that you don't have without the verifiable credentials. It obviously can also be used for self-description, so that you also have guarantees. If your provider, for example, gives you a credential that describes the product and it's signed with this key, then you have the options to later even go to court if something is broken, and you have the verifiable credential to prove what the provider offered you. Now we also have the idea of how to acquire rights to use a product inside a data space. We always have our data providers and our consumers, and obviously in most cases a data provider just does not want to give its data away for free to anyone, but instead wants to define who is allowed to consume the data, and most of the time will also have the needs to for example, want to monetize the data. Yeah, so the consumer needs to buy access to the actual data product in order to use it. To enable this, we essentially have the way of acquiring the rights to use a product inside our data space, inside our FIWARE data space. Sorry. That logic of acquiring the rights to use a product is essentially built about that we give the access to an organization what policy or establishing policies authorizing users of another organization to actually use the data. So an organization acquiring access to the data product in our consumer will be through the process of acquiring the rights allowed to issue certain verifiable credentials to its users that they then can use to access the service. In an example of, let's say, park and gardens management system, yeah, we have a data provider that offers a system for parks and gardens applications. In this park and garden application, our consumer organization buys access to it, and our consumer application then gets the right to issue certain credentials to its users. It could be a visitor of this park, of the parks and gardens, but it could also be some gardener that just wants to use this application to control stuff. And once the consumer has bought access to it, the provider will automatically establish certain authorization policies that give the different users of the consumer organization, depending on the contents of their verifiable credentials, access to this service, so that our consumer organization can independently decide which users should be allowed to use the visitor application and which should be allowed to use the gardener application of our service. We are also able to define different packages of product for that. You can imagine some premium access or some regular access to this application, which might have different levels of details, different functionalities. So you might have applications that only give access to some downsampled data, and if you get premium access, you get the raw data or the data in, let's say, different visualization levels. Essentially, all ideas that you could have with the different levels of access for, or let's say, of quality for an application that, yeah, inside the web, I would say. Once the participant that acquired rights to use the product, we're using concept where the participant in this case is the consumer organization, becomes the trusted issuer of this verifiable credentials. Yeah. So in general, as mentioned, the consumer can issue the credentials independently to its users and services. But in order to be accepted, so in order for those credentials to be accepted by the data provider, the participant needs to become a trusted issuer of these credentials. That means our data provider now trusts the consumer to use or to issue those credentials in a trusted way, so that it does only give them to users or to services that are trustable inside our data space. Those credentials can then include a certain number of claims, again defined by the trust relationship that is established between provider and consumer through the process of acquiring those rights of the products. The acquiring organization then can again decide independently who should get which verifiable credentials linked to their organization. So the employees, the customers, the device and service agents even might get a different level of verifiable credentials because they, for example, might not have interest in using any graphical user interface, but they need access to some backend APIs. That's something that can be decided on by the consumer organization by just assigning the right verifiable credential to the services. That also has some benefits for the product providers because in, let's say, traditional data offering or application offering in the current internet, product providers usually also have to manage the identity of the users from their customers. So if I buy access or if I offer an application, I have to provide the identity management for this application. And the users usually get registered at my site. I have to manage them. I also have to respect their GDPR claims, for example, when working with employees or even with customers of my data consumer organizations or third-party organizations, then I have the whole complexity of managing the identity of them. In our decentralized architecture of the data space, that burden completely is taken away. So the provider itself does not know anything or does not need to know anything about the users and services itself. The level of knowledge that they need is defined in the verifiable credential. Only the verifiable credential issued by the consumer organization contains the information that the provider also will get. And it does not even have to store them in most cases. Yeah, so now to give back some idea about our fundamental positions on data spaces. I think some of that should be already clear from what I explained before. Data spaces are not just about the business-to-business exchange of data sets. We see a lot of this in the discussion about data spaces, that there is the idea of data spaces just being used for business-to-business exchange. That means organization A gets data from organization B. This completely leaves out the idea of that, or the, let's say, even the technical requirement of somebody carrying out this data transfer. Yeah, it's usually not an organization that gets the data. It's either a data service, or it's a software agent, or it's a user that wants to get this data and that also processes the data and that will access the data. Therefore, in our data space, we not just talk about business-to-business exchange. Obviously, the trust relationships inside the data space are between different organizations and therefore somewhat business-to-business. But the actual data transfer, the actual data access is not just a business-to-business exchange. We have the invocation of services. Those services are not just plain data sets. They can be used for data processing. They can even use for actuation. We can give access to data interpretation and visualization apps. So let's say not our organization is consuming the data, but the data analyst of that organization is accessing the data and using it inside a data app, inside an interpretation or visualization app. That might sound like a small differentiation, but it's a much more powerful concept if you think about it, because then you give if you consider the users and the services really as the part that is carrying out the data exchange. You can build applications, APIs, data sets, data operations in a more, let's say, more user-friendly, user-targeting manner, and therefore making it also be more interesting for the consumer organizations to actually use them. And obviously, yeah, I now said it multiple times, in the FIWARE data space, we have the user linked to the consumer organizations to access the service based on their profile inside the organization. I have the example of the data analyst accessing the data. You could, for example, offer services where your consumer organization can decide different levels of access for their data analyst and for their working student, depending on the needs that they have. Maybe even thinking about the cost of those transactions. So in the data space, you might have a fee for accessing the data, and you want to not have your working student consume this whole fee. So you give it a different level of access than to the data analyst itself. With that, data space has become a much more powerful vision for an ecosystem that drives innovation. So if a provider can offer products that range from simple services like simple data sets to complex applications comprising several services, they can even build services using backends of other participants in the data space. I, as a consumer organization, can offer my customers applications that are assembled together by other providers' applications, where they already have the business logic available, where they already know how to visualize the data, and I just include it into my system and therefore build a more powerful application for my customers. I, as an organization, can extend my system architecture through the integration of services linked to products by third-party providers. For example, if I have an IoT device that does some management of energy flows, for example, I could now use the prediction engines from third-party providers to give those IoT devices data and access to data services that enrich that make their decision making much more powerful, just by including them into my data space. Yeah. But for any data space to really become this truly open ecosystem where those organizations can dynamically join and interact, we need multiple levels of standards that are agreed as part of the governance of this data space, so that we can really make this, let's say, vision of a data space reality. Because obviously, to interact through technical services, through APIs, we need to agree on a set of those standards, on those APIs, that all parts of the data space understand each other. That's what I will now go a little more into detail. Where do we address interoperability and how we do it? Obviously, if we have this decentralized identity management, we need to agree on some standards on how to define identity inside our data space. We need some rules associated to the format of verifiable credentials that we use inside our data space. Obviously, verifiable credentials itself would be the first standard that we have to establish for our data space, because only if the provider understands the verifiable credential and the consumer is able to issue them, we can exchange them and base our identity mechanisms on them. We also need to define protocols that are used for issuing and exchanging those verifiable credentials. So if I want to exchange a credential between or if I want to give my user a credential, I need to define how the user gets the credential, and then we also need the definition of the protocol, how the user itself is now exchanging the verifiable credential or presenting it to the provider itself, to the data provider, in order to authenticate itself. That's something we need to define. On a further step, we also need a way to define the policies. So policies essentially are the thing where we define what some verifiable credentials or some holder users of verifiable credentials are allowed to do at a data provider. Let's say I have my consumer assigning a credential to my user, and this user is coming to the data provider. Then the policy defines what this consumer is allowed, or this concrete user is allowed to actually access inside the application. We need a policy definition language for that that specifies the concrete authorization policies. I mean, the easiest, let's say, example of that is that we have some roles defined inside the verifiable credentials, and then the provider decides based on those roles what to do. In a data space, we have often much more powerful concepts or much more complex ideas on what we want to base the access on. And those rules need to be specified in a language understood by everyone inside the data space. So we need a policy definition language. And we need some global data space registry services that enable the trust within the data space. The most obvious required such service is a registry where the participants can look up if an organization that they are contacted by is actually also a part of the data space. So we need some kind of registry for participants in the data space. There are some additional, not always required, but sometimes helpful registries inside the data space where you can define common schemas, common protocols, and so on. But we all need to define for a data space what APIs they are offering and what requirements we do have on them. So we need to define some global data space registry services. Beyond that, we also need to define the APIs and protocols for the concrete exchange of data. So the consumer and the provider both need to understand the data that is accessible through the APIs or protocols. So it could be services, or it could be APIs like, for example, NGS ILD, if you want to do some actual data access, for example, in IoT data exchanges, or some, let's call it, near real-time data access and data processing services. But it could also be APIs and protocols for the exchange of files or large data sets, like the S3 protocol that we all know, or FTP, stuff like this. So we need to define that on a data space level, because if the consumer does not understand the protocol the provider is offering, then we don't have a connection or a data exchange that makes sense. We also need to define the data models, so a common vocabulary and semantics, or common formats for the serialization of data. Because again, if the provider is offering the data in a format or with a vocabulary that the consumer doesn't understand, there is not real value. If the consumer expects XML and the provider offers JSON, then we have a problem, because let's say the offered data is not really of any value for the consumer. And we also need some mechanisms for publication and discovery, because it's nice that our provider has essentially data to offer. But if there is no way where a consumer can actually find out what products are actually offered, and it does not understand the format or the specification of this offered data, and how to contract it, how to get access to it, then we also have an issue, because then we don't have exchange inside our data space. So we need publication discovery mechanisms in the data space. And then we also need a commonly agreed process to acquire the rights to use this product. We already learned that the actual process of acquiring the rights of a product in the FIWARE data space happens essentially by building a trust relationship between the consumer and the provider. But we also need some APIs to enforce that. So a standard API where the characteristics of the products can be reviewed, and where then also actually a process of the acquisition happens. So an API where the consumer can go to the provider and say, I want to now buy access to this concrete product. And then the provider will have to go through a standard process in order to give the rights of this to access this product to the consumer. This is something that also has to be defined on data space level. Now go a little into the actual standards and protocols that we're using for that. I will start with trust and sovereignty. So this is essentially everything about the decentralized identity and access management that I talked before. And our decentralized identity management and authentication relies on some well-established protocols. The first one is the definition of decentralized identifiers and verifiable credentials. Both formats are governed by W3C, and yeah, I would say well-established around the whole decentralized identity and access management ecosystem. So this is not something invented for FIWARE, for the FIWARE data spaces or by FIWARE itself, but governed by a much broader community. And we are using, for the exchange of those credentials and for the resolution of those decentralized identifiers, protocols from the OpenID foundations. They are under the, let's say, under the headline of OpenID for verifiable credentials, because they're essentially an extension of the well-known OpenID for OpenID Connect and OAuth 2 protocols. They are compatible with the currently defined UD wallet reference architecture, which becomes a requirement for European member states, I think beginning of January 27, and then increasingly get more important into the daily exchange of data in the European Union. And we're using therefore the issuance, the OpenID for verifiable credentials issuance protocol that defines how a user or a service gets its credential. And we have the exchange protocol, which is the OpenID for verifiable presentation protocol, which defines how a user presents its verifiable credentials to a data provider, so to a trusted participant. When I want to authenticate, I need to reliably present my credentials to someone, and the OpenID for verifiable presentation protocol defines how this is happening. in an open ecosystem where we have organizations joining, the trust framework itself requires a little more. So we require a registry of trusted participants where the verifier can check and determine whether an organization is a legal entity within inside our data space. We need a registry of those trusted issuers. And for that, we are relying on the EPSI APIs. EPSI is the European Blockchain Service Infrastructure. And EPSI itself defines a number of, beside the service that they offer, these define a number of open APIs for various topics. One of them is in the field of verifiable credentials, where they were one of the first drivers in Europe. And one of those APIs is the Trusted Issuers Registry. This is essentially an API specification which allows you to look up if a certain identifier is registered for certain permissions. So is a certain issuer allowed to issue credentials of a certain type? It's possible to define additional properties for this issuer. And that's what we're using as the global data space, as the service to provide the issuers and participants inside our data space. That's what we have in the slides before called as the global data space registry services. The most important one is the Trusted Issuers Registry, where you can look up if a participant is actually a participant of the data space. We integrate a number of additional protocols and services that might be used, for example, for onboarding, where you can already have checks about the organizations coming into your data space, for example, of them being actual legal person that complies with certain rules of your ecosystems. For that, we, for example, rely on the Gaia-X digital clearinghouses, where we can already check if a legal person is actually a company. We could, for example, enforce stuff like they are coming from certain regions in the European Union and only allow access to the data space if they fulfill those rules that are defined for a data space. In order to have the authorization part of our framework, we're following the well-established PP, PDP, PIP, PAP architecture for attribute-based access control. Attributes in this case are the claims of the verifiable credentials, and we're building the access control based off that. If you don't have a full understanding of what the PXP stuff means, this will come in the next part of the presentation. But this is the essential architecture that we're using for the authorization and for defining the policies that are actually enforced, those ABAC rules. We are using ODRL. ODRL is the open definition, open digital rights language, which is a policy definition language, also I think by W3C, yes, by W3C governed, which is built to define the access rights, or let's say the rights on top of digital products or digital services, data, and so on. We're using that inside our data space to define essentially every access to products, to data sets, and to services, etc. We, for example, support we support different protocols, different profiles there. One of them is, for example, the Gaia-X ODRL profile, which is built for verifiable credentials. So we can use rules from Gaia-X or in a format defined by Gaia-X to define access to our services based on verifiable credentials from the Gaia-X ecosystem. Now, in order to go further in terms of value creation, because obviously, as I mentioned, we also have the discovery and providing aspect of a data space. We need some way to describe data, services, resources, products, offering, and so on in a manner that everybody inside the data space understands. We need a way to publish this data and allow the consumers to actually discover the offerings itself and then facilitate the connection between provider and consumer to make the contract negotiation itself. Contract negotiation in our data space is always peer-to-peer because we don't have that central instance where you have, let's say, somebody doing the offering for you. But we offer also the option to have some centralized marketplaces in order to provide more visibility for the services or for the offerings of the single data provider. In order to provide the APIs for that, we're using the TM-Form open APIs that can be used for managing offerings, support contract negotiation via marketplaces or through the connectors itself. TM-Form APIs are a set of APIs governed by the TM-Form organization. TM-Form is an organization coming from the telco background, building APIs for those, let's say, product lifecycle and the marketplace services around them for multiple years already. So it's a well-established set of APIs that we're just adopting here. That allows us, for example, an easy integration with Dome Marketplace, to have services offered by FIWARE Dataspace connectors in Dome. We already also have a layer of compatibility with the Eclipse Dataspace protocol, so you can also use the catalog, the contract negotiation, transfer process, and so on for all those offerings inside the FIWARE Dataspace connector, despite being defined through TM-Form APIs. And we also have support for monetization based on this TM-Form APIs. You can see an example of a marketplace interface here. Since we rely on established open source APIs, there are already existing graphical user interfaces to display the offerings and the catalogs itself provided through the TM-Form APIs. In addition, we are also providing or can provide more machine-readable catalogs. So we also give the access to the data space in a DCAP-v3 compatible manner at the connector level or even at the data space level, so that we can allow global catalogs or marketplaces through DCAP-v3, so that it can be used by, again, well-established discovery mechanisms for data. And for data exchange itself, as mentioned, providers and consumers need to talk the same language in order to understand itself on transport and syntactic levels. So they need to use common APIs, and also on a semantic level, so they understand common data modules and vocabularies. While we don't enforce any API or any protocol itself, in theory or in general, the FIWARE Dataspace connector is agnostic to that. So you could provide any protocol that you want to use. We're recommending some. So obviously for the exchange of digital twin or digital product data, we are recommending NGS ILD. We would recommend something like S3 for large data exchange and MCP A2A for the exchange between AI agents. We have a level of integration by default already for all of them. But the FIWARE Dataspace connector is flexible enough to essentially integrate any other protocol by configuration if you have a use case for that. We would also recommend the adoption of common data models instead of inventing new data models, because that's much easier for, let's say, for the plug-and-play idea of organizations joining a data space. There are multiple references that could be used from ISO, XAREF, and so on. And obviously, from the FIWARE background, we would also recommend Smart Data Models Initiative, which brings a hub where you have models that can be mapped into JSON and JSON-LD as serialization formats, so that all partners understand this, or all participants understand the data in the same way. We allow data exchange through let's say, level of transfer control. This is implemented by the Eclipse Dataspace protocol. So the FIWARE Dataspace connector also offers the full set of Eclipse Dataspace protocols. So you can do transfer process or can control the transfer process of data in the FIWARE Dataspace through the transfer process protocol of the Eclipse Dataspace protocol. But again, this is not a requirement. You can also just do some access to web pages for exposing applications for data visualization. In this case, the protocol would be plain HTTPS, for example. Okay, now that you have an idea of, let's say, the the plain, I would say, vision of FIWARE data space in FIWARE, I would go into more details of the FIWARE Dataspace Connector. I think this is a good point to just have some first question, if there are some. If not, I will go just straight on. So any direct questions, or should I just continue? Okay, then I will just continue and give you first overview about what the FIWARE Dataspace Connector, how the FIWARE Dataspace Connector looks like from an architectural point of view, in order to actually make the data space or a FIWARE Dataspace reality. So the FIWARE Dataspace Connector itself is essentially a set of microservices. Microservices that each of them plays a certain role or fulfills a certain role inside the connector to offer certain functionality that can but not always needs to be used for offering the data or for accessing the data that you want to have in your data space. In general, the basic deployment idea for FIWARE Dataspace Connector is based on Kubernetes. So our standard deployment environments are always Kubernetes cluster, where you deploy a number of services for your organization, depending on the role it wants to fulfill inside the data space. So a data provider, for example, has some more requirements to have a connector as being part of FIWARE Dataspace than a consumer. If you want to just consume data, you need a much smaller dataspace connector in FIWARE Dataspaces than if you want to be a FIWARE data provider. And even for a data provider, you can have different levels of, let's say, of size of your connector, depending on what you actually want to do. We have various sets of components that you will always have in a data provider. For example, we always will need an authentication services. The authentication services are the light blue here. So we will have a verifier, we will have an authentication portal, we will have some trust lists that are required by a Dataspace Connector if you want to provide data, because without them, you cannot give anybody any trusted access. You can still give your data away to anyone, but that's not the basic idea of data of a data space. We also will have a set of authorization services. Those are the famous PXP services that I already talked about. We will go into their responsibilities a little deeper later. But in addition, we will also have some services for offering catalogs and the publication of it. We will have something for contract management that then will actually integrate your catalog with the system of the Dataspace Connector. We can have additional services depending, for example, on the needs that you have from a regulatory perspective. So we might have logging services. We might have remote attestation services. We will have some operational focused services like monitoring. But all of them can be are more or less optional. So you can just plug together the Dataspace Connector with the functionality that you really need from the role of your organization inside the data space. Now I will go into the more details of the single, or let's say of the building blocks of our FIWARE Dataspace Connector. And I will start with the authentication part, because the authentication is essentially always the first touch point to a connector. If a consumer will connect a provider organization, then the first thing that it has to do, it has to authenticate itself. Our authentication part consists essentially of a verifier service. The verifier is a service that provides the OpenID for verifiable presentation protocol and allows the user to identify itself with verifiable credentials. So we have a consumer, a user empowered by a consumer coming in, sending its verifiable credentials to the verifier. The verifier will then do the actual verification process and will decide if this is up and will return an authentication result. The verifier itself uses various trust lists. So as mentioned, the API Trusted Issuers Registry are used here. We have multiple levels and can define multiple levels of trust lists. So we will have global trust lists like the participants list. So if the verifier will check if our consumer or if the client contacting us is actually part of a participant of our database. But we will also have some local trusted issuers lists that might contain information if our user is actually, or if our client is actually trusted in the concrete exchange it wants to interact with. That means if a consumer has bought the access for a data product, our provider will insert this into its local trusted issuers list, and based on that entry, we then can decide, is our client actually allowed to access the data it wants to see or not. And if it's not part of this trusted issues list, we can essentially already fail the authentication flow instead of forwarding and then later having additional policies in place to deny the access. Our verifier is configured through a credential config service API. So you can do some very fine-grained definition of which service requires which credentials and which levels, and where should the trusted list for those services exist. This is configured through a credentials config service. And we also have a part of the verifier, which is called the authentication portal, which is essentially a front end that can be integrated into other front-end applications that you want to use to authenticate yourself. So if you have a user interaction, the user will usually go through a front end, and in a similar way as you might know it from existing IDP solutions like, let's say, Keycloak, you can have a web page that offers you the login capabilities. That's what we call off-portal here, and that's also part of our authentication services that can be used but not necessarily have to be used. Now, once the authentication is fulfilled, the client essentially gets back its authentication result, which is more or less a JWT token with some information extracted from the verified credentials. And then we are coming through the authorization set of components. The entry point to our actual backend APIs in the FIWARE Data Space Connector always goes through our policy enforcement point. In the FIWARE Data Space Connector, the policy enforcement point usually is fulfilled by RP6. RP6 is an API gateway, open source API gateway, mostly maintained by Red Hat with a powerful community behind. And it's the entry point for all external requests towards the Data Space Connector. Be it the downstream applications like our services that we're offering, like the data sets, but we're also using it to secure stuff like our catalogs and so on. The policy enforcement point itself does not much beyond routing and requesting a decision on policies. The actual decision on policies is happening by the policy decision point, and the policy decision point is the service that evaluates policies, the OUL policies that were registered for the certain route or service, and then decides if the request should be now denied or allowed. That's also the only information that the API gateway gets back. So it only gets information, should I allow or deny this request, and then it carries out that decision. The policy decision point gets its policies from the policy administration point. And the policy administration point is where actually the policies itself are managed and translated for the PDP to be understood. I will have more information about translation and so on in the next part of the presentation. But that's essentially where we can register our ODRL, and then it will become part of the pipeline of the Data Space Connector. And we have a fourth important part of the authorization services, which is the policy information point. The policy information point is essentially an optional service, and or let's say a role that provides additional information for the policy evaluation. So you can imagine policies that only would allow access to certain at certain time. Then you need a provider of time. This time can be provided by a policy information point. There are other ideas that other things that could come from policy information point. But yeah, that's the third component as fourth component as part of our authorization services. And that's the, let's say, very common PXP architecture. Yeah, that's the second set of components that you will have essentially in every provider-side data space connector in a FIWARE data space. In order to actually offer the services, we also will have a set of components that we call contract management. The contract management is the components that we're using for offering our marketplace functionalities, for defining product specifications, services, product offerings, and so on. As mentioned, our API for that is the TeamForm APIs, which is an implementation of those APIs that our marketplace uses essentially as a backend. So if you want to have a graphical user interface, we have the BAE marketplace that uses the TeamForm API as the backend for having the product offerings and specifications and so on to be shown. And that also stores all parts of the negotiation process. And then we have a dedicated component called contract management, which will integrate the product flows into the internals of the data space connector. So once the right to use a product is acquired through the marketplace or through the TeamForm APIs itself, contract management is responsible to carrying out the entry into the trusted issues list, applying the policies, provisioning certain routes, and so on. It essentially does the provisioning of the whole product to make it accessible for the consumer. So that's the responsibility of the contract management component, while the TeamForm API is essentially the data store or the backend where you can transition the whole contract negotiation until you get access to your service. And again, BA Marketplace is essentially graphic user interface for marketplace functionalities, so that you can search for the data offerings that you want to have or the applications that you want to have and buy access to them. And as a fourth important point, as mentioned, we are also supporting the data space protocol. We're doing this through an integration with the Eclipse Dataspace Components. We have implementations of the Eclipse Dataspace Components ourselves. They are called FDSC EDC, which might sound a little weird, but makes sense from a logical perspective. We are providing them in two different flavors. So we have one FDSC EDC control plane for OID for VC, and we have another one that supports the decentralized claims protocol, because as I already mentioned, let's say the default authentication authorization protocol inside our FIWARE data spaces is built on OID for VC. So we also have built an implementation of the EDC that supports the OID for VC protocol. And in order to provide backward compatibility with other EDC-based connectors, we are also supporting a control plane using the decentralized claims protocol. In case of the EDC being used with DCP, we obviously also need Identity Hub to support the decentralized claims protocol. So this can also be deployed as part of the FIWARE Data Space Connector and being directly integrated into the Data Space Connector. I will go into more details of the Eclipse Dataspace protocol integration, I think, in the Friday session. There we have a dedicated space for that. So I will not talk much more detail about that. But in general, we are supporting the full data space protocol through DCP and through OID for VC. Yeah. So that was the basic architecture of the data space controller. And now the rest of the sessions, starting with now the decentralized identity and access management part, will go into the actual details of the functionalities of the connector. Yeah, and hopefully we'll give you more idea about how those building blocks actually work. Again, do we have already some questions? Yes.
Hi, thank you for. Can you hear me?
Mm-hmm.
Okay, thank you for your presentation. I noticed in the data space, let's say data space is a whole body. So inside there will be shared data, right? So we paid a lot of attention on authorizing if the user is if the consumer is the consumer themselves, and the data provider is the data provider themselves. So how do we guarantee that the consumer, the data from, how does a consumer can confirm the shared data from the data provider has not been exposed or even tampered?
What do you mean with exposed? So being tampered is
yeah.
Yeah, continue. Sorry.
Yeah, thank you. So the data provider will provide the data to the consumer, right?
Mm-hmm.
So how do we share the data? Let's say through a path or using any protocol, maybe. So on the way, when the data going from the data provider to the consumer, how could the consumer confirm that the data on the way is not exposed or tampered?
So actually, that's something that the Dataspace Connector itself does not take care of. Having the data untampered is something that we mostly delegate to the application. So the application itself could obviously sign the data that it provides. We could reuse the standard mechanisms that we have here in the FIWARE Dataspace environment. So let's say the data provider could just sign the data that it sends to the user and to the consumer organization. The consumer organization then verifies the signature against the public identity of the provider. I think that would be the easiest solution, but that's not something directly built into the FIWARE Dataspace Connector yet.
Okay, thank you. What you mentioned just now is like the private key and public key, right?
Yeah. So as you will see in the decentralized identity access management part here, that let's say the whole exchange between consumers and providers in the Dataspace Connector is essentially something built around private public key. Okay. So we have identities that can be used for that.
Okay, thank you. I think that answers.
Okay, we have another question. Okay, Afan, I guess.
Hi, yeah, thank you for your presentation. I have two questions. The first one, you might have already explained it. You've explained about some sort of dashboard where we can like analyze the climate data or something like that in a house or something. And I just wanted to know, like, we have a software, let's say, and that software is like that dashboard requires live data of some sort of sensor in a building or something. And then this transfer of live data happens through the connector, or only the negotiation happens through the connector and the service provider sends another API or something to receive the data? That's my first question. And the second question is that, okay, like aside from the exchange of data, let's say we want to like sell some applications, softwares. Does FIWARE makes us a marketplace available for, like, I don't know, Google Store or something, where the images of the softwares are over there to be downloaded, or like the metadata of the application is only over there to be queried, and then they're gonna send the images of the software, like the service provider is gonna directly somehow send the image of the software application?
So for the first case, yes, the data flows usually directly through the Dataspace Connector, because the Dataspace Connector itself will then also take care of authorizing the access to this data. So you have your, let's say your data application on the consumer side, and you want to consume the data from the provider and stream it there. Then this front-end application will go through the Dataspace Connector. It has to authenticate itself, either being the service agent itself or the software itself, or by, let's say, even depending on the user model of this application, it could also propagate some information about the users. That's very specific about the application itself. But the access goes directly through the Dataspace Connector, because the PEP will then decide if you are actually allowed to access this data. And for the second question, this is not necessarily about what FIWARE provides. So we provide components for this marketplace and for offering stuff, and even for there are solutions for downloading stuff. But but this is something that is then more reliant on the data space itself that you want to become part of. So the data space itself can offer central marketplaces where you can, where all providers offer their data to stick together. You as a provider can run your own marketplace interface and backend where you offer that. Or there are solutions like, for example, the Dome marketplace, where you can offer your data already in a European marketplace and make it accessible. So this is more specific to concrete implementation of the data space than to the concept of the data space itself.
Thank you.
Okay, Cristiano?
Yes, thank you very much for an interesting presentation. My question is, among the set of microservices comprised in the FIWARE Dataspace Connector, which are amenable to deployment on small devices, such as, for example, single-board computers, and in your opinion, which would you recommend for such an edge deployment?
That depends a lot on what role you want to play in this, what your device should play in the data space. If it's a plain consumer,
The provider, essentially data providers.
The data provider itself is usually not something that will be deployed on small edge devices. So I think if you have a small edge device providing data, it will usually be connected to a data space connector acting in the role of a provider deployed in some Kubernetes cluster. So the especially provider side is not built to be deployed in small edge devices. That's not the, let's say, the scope or the idea of that. If you have a device providing data, then it will usually stream it to some connector that will take part, that will then play the role of the provider and data space connector.
Okay, thank you very much.
Okay, you're welcome. Okay, then maybe now the last question, because then we probably need to continue first. Maria?
Okay, hi, thanks for the presentation. So I would like to know how our entity is allowed to be a trusted issuer of verifiable credentials. I mean, you said something about the Gaia-X ecosystem. Is this a mandatory step in the...
No. So the Gaia-X ecosystem is something that can be used for becoming part of the data space and becoming a trusted issuer or trusted participant, but it's just one of the solutions. So most data spaces will define some rules on whom is allowed to participate. And ideally, those rules can be applied automatically. If you want to apply them automatically, you need some onboarding services that use reliable sources of information. One of those sources of information could be Gaia-X. And that's something that you can use to become a trusted issuer inside the data space. But you can define for a given data space the rules for becoming participant yourself. So it could also be, and that's actually something that happens still in reality, a process where somebody sends a signed PDF and then somebody adds it manually to the list. So that's some part of the rules that the data space needs to define for themselves. We can offer certain ways to automate that or to make that process easier, but in general, that's to be defined by the data space.
Okay, thanks.
Okay, you're welcome. Okay, then I will continue with the part about decentralized identity and access management. Yeah, this will go into really the details of how decentralized identity and access management works, and then also how we are applying it inside a FIWARE data space. Because in order to really understand how the data space works in FIWARE and also to get a better idea about stuff like, for example, how should I become a trusted issuer and what does that mean? We need a better understanding of decentralized IAM. Yeah, the first question is obviously, why do we actually need decentralized IAM? I think from the first presentation, we already have a basic idea of why we need it, but I want to go into the more details of that again. So a data space itself consists obviously of different participants. Those participants can have various roles. So they can be provider, they can be consumer. We might have participants that just play the role of a marketplace, essentially connecting just the offerings from the providers with the consumers that want to use them. In this participating organizations, we have various actors. We have technical actors like services, like AI agents, like IoT devices, and so on. And we have human actors, those that act for the various participants. All of them might connect with each other. Besides being part of the data space, there is not another connection between those participants. So data provider A does not know anything about data consumer A, beside the fact that they might become part of the same data space. And they especially don't have any knowledge about each other's actors. So data provider A does not know the humans that are act for consumer A. And consumer A does not know about the technical services that act on for data provider B. In order to solve that trust relationship, we actually have to solve some questions. So how do we identify actors? How does provider C recognize this user as part of consumer A? And how do they authorize their actions? So how does provider C know that this human is allowed to actually access the data by being part of consumer A? And how do we connect them with the organization? So some client does connect me. How do I know that this client is part of a certain organization? In this case, for example, consumer A, organization consumer A. In order to do that, we need some mechanisms, some identity access mechanisms. We have a couple of other problems to solve in that. So what do we do if new participants join the data space? So we can assume we already have established some trust between provider A and consumer A and so on. But if now a new participant joins, how do we establish the trust relationship between this new participant and all the participants that are actually part of the data space already? Or what do we do if a new actor joins to the participants? So let's say consumer A already told everyone in the data space that those are my human actors. Now provider B onboards a new employee. How do the other participants of the data space know that this employee is now allowed to act on behalf of the data provider B inside the data space? Now we have a number of solutions already out there in the web that in general could use something. The easiest to think of is obviously the central login, but it's very easy to use. It puts all power into a single entity. It's a very powerful data sync, and it takes away the control from our actual participants. So this very much goes against the idea of the sovereignty that we define for the vision of our data spaces. We now can talk about federating the identity, obviously, so that we have less reliance on the central IDP. We still rely on the central providers that we have here. We have the issue of the increasing complexity with the number of providers that is always common with such systems. And we still have somewhat given away the sovereignty about our users and about the control that we want to have. So let's say the traditional IDP system or IDP models that we have out there are not what we want to have for a data space, because it goes against the fundamental ideas of having sovereign organizations that can act on their own, that have the power about their users, about their services, and that can assign this access themselves independently from everyone else in the data space. Now, in order to solve that, as mentioned, we want to use decentralized identity. The basic idea of decentralized identity is that we want to copy the good things from the physical world. We want to augment it with digital powers, then we can preserve the required properties and then adapt it to current legal frameworks so that we stay prepared for the future. The easiest understandable idea of the decentralized idea copied from the physical world is the wallet with our cards. Those cards contain a lot of properties, a lot of information about ourselves that we can use without connecting the issue before. So think about our passport that we can show everyone without connecting the issue itself. To be more concrete, what connects, what is the identity of a person itself? We have our identity in, let's say, presentable form often with us in our wallet, in form of the national ID card, in form of a driver's license, in form of employee badge, club membership. There are stuff like proof of residencies. There are some educational focused parts of our identities like diploma. And all of those parts of our identity as a natural person can be used and can be shared with others to actually authenticate ourselves and get some, and even to offer ourselves some stuff that we can do based on our identity. The same concept is true for legal persons. So a company itself also has a number of identity features that it can use and that it requires, like their business registry ID, something like the legal identifier, some ISO certificates, bank solvency, tax compliance, GDPR compliance, and so on and so on. So there are various parts of the identity of a legal person that also can be shown and used to get some stuff. In the real world, as mentioned, we're usually doing this with cards from our wallet. And as you will see, I will now give descriptions on how this actually happens on a schematic way in the real world, because that makes it easier to then understand how it happens in the decentralized identity world, because you will see this is essentially the exact same way. We have the so-called trust triangle between issuer, verifier, and holder. And that's something that we will use not only in the real world, but also in the decentralized identity world. If I want to use my national ID card, then I have an issuer of this ID card. Yeah, the government is registered usually for a German city, or for so I'm from Germany, so my issuer of an identity card is the German government, and it's essentially registered as part of the European Union, and we are using the schemas that are also defined and trusted in the European Union. So I get issued a document. This document is my national ID card, and my government hands it out to me. With having now this card, I'm the holder of this national ID card that follows the common schemas defined by the European Union and some additional standardization bodies. Now, if somebody comes and asks me for authenticating myself, I can present my identity without asking the government for permission, without contacting the government, because I'm the holder of my identity now and can present it. I can present it, for example, to the police officer, which then starts to verify this document. My identity card contains certain identity features where it can be checked that it's actually a trusted, or that it's actually issued by the government. And that it can be that the verifier can trust in the properties written on this document. So because it's issued by the government and it can be independently verified, the police officer now can trust my address, my name, and so on. It can also do this because it uses a schema that we both understand, and a schema that is well defined, because it is a standardized card from, in this case, defined by some European Union bodies, so that every one of us understands that. Beyond that, this card is also bound to me because of the picture on the card, so that it's also secured that only I can use it. So that's how essentially authentication happens in the real world. And now let's have a look how this happens with verifiable credentials, because it happens exactly in the same way. You can see we have the same trust triangle here, just on a more technical level. So we have an issuer that is registered in our verifiable data registry. The verifiable data registry would be in the database our participants registry. By being registered there, our issuer can now issue verifiable credentials. The schema of those credentials it uses are usually commonly agreed. They can be provided by a central verifiable data registry. They can even be agreed on off-band. So that's to be defined. But it's important that all of them agree on the schemas that they use, so that everybody understands the same kind of credentials to be used. Our issuer now issues credentials to the holder. So the user, the service, the AI agent, whatever, gets a verifiable credential issued from the issuer. That's the document here. So a verifiable credential essentially is a JSON document that now my user can hold and use to authenticate itself. This credential is signed by the issuer. So similar to my ID card, it contains authenticity features. Due to the signature, everybody that gets the credential can verify that it actually comes from this issuer that is registered as a trusted participant of our data space. But now my user, independently from the issuer, goes to the verifier, so let's say to another participant, to the data provider, and wants to do something, the verifier of that provider will request authentication. It will say, okay, now you're here, please authenticate to me. Then our user can independently present this credential to the verifier. The verifier then obviously can check the signature, can check that it's a schema that it understands, and then can trust on the properties in here, eventually through the indirection of trusting this issuer. Both of them are part of the same data space. Both of them understand the same schemas. And since this issuer issued the identity to this holder, the verifier trusts the presentation and the identity that it gets presented from the user. That's the whole idea of authentication inside a data space. We have a user acting independently from the issuer. We have a verifier trusting on the authentication and understanding the identity of a user without having it pre-registered, just by building the trust relationship through the data space to the issuer. That's the, let's say, the basic principle of decentralized identity and access management in a FIWARE data space, or in most data spaces, that will make all the let's say exchanges that we described work. I will now go into more details of the concrete components of this flow, but this trust triangle and this exchange is important to understand and important to keep in mind, because that's the basic of the trust inside the data space. Now, I use the word a lot, verifiable credentials, obviously, but now what is a verifiable credential? A verifiable credential is essentially a tamper-proof digitally signed document that securely proves claims about an individual or an entity, allowing verification without directly involving the issuer. What does the verifiable credential exactly is? So it's specified by W3C, as I already mentioned. We have now the verifiable credentials data model 2.0. It defines the structure of a credential and the security features that it should have, and so on, which of such credential documents. Verifiable credentials essentially can contain any kind of data. Usually it should be JSON representable. You could also put binary data in there, but then it might become hard to handle and so on. But in general, you could put any kind of data into a verifiable credential. Verifiable credentials are tamper-proof by design because they have digital signatures as part of the credential itself, and they are already adopted by various regulatory and standardization bodies. As mentioned, we're using the OpenID for verifiable credentials protocols, so they are adopted by the OpenID Foundation. If we talk about data spaces, there obviously is also the decentralized claims protocol, which relies on verifiable credentials. And from a regulatory standpoint, we have the UD wallet reference architecture, part of IDAS2, which defines how authentication and the handling of such credentials will happen in the European Union, which also becomes part of European regulations at the beginning of 27. So this is already well adopted and not some, let's say, proof of concept stuff, but it's something really could be relied on. Now, how does a verifiable credential look in the wild? It essentially contains of three parts. Credential contains some credential metadata. It contains some claims that contain the actual payload about what we want to attest about a user, and it contains the proof section, which then guarantees for the integrity of our verifiable credential. Now, go into what each of those parts actually contains. The metadata itself provides the contextual and technical information about the credential itself. It, for example, defines us what is this credential and how do I need to interpret it when I get it. It helps the verifier to understand the validity, the provenance, and usage context. So not only what are the contexts and how do I have to understand them, but also is this credential still valid, from which time to which time should it be valid, who issued it, and stuff like this. All of this is part of the credential metadata. That's not yet part of the payload, which is actually contains the attestation about the user. Like, let's say if we go back to the idea of our identity card, that's the part where you have the, let's say, the number of the ID card, or you have the body that issued it, let's say in my case, German government, but not the address or the name. So that's a different part. That's now the metadata. Now, what parts do we always have? We have a context. The context provides the context for interpreting the data within the credential. This is often used to link schemas and standards, so that the verifier actually knows how to understand the actual contents of the credential. Very important is also the type. So we can have types. Every credential is a verifiable credentials, and then you have some concrete types, like, for example, national ID, which will help the verifier to interpret the purpose and the contents of the credential. So address might have different meanings depending on the type of a credential. In a national ID card, it's most likely the address of the person. If you have a credential attesting something about an organization, it might be the business address of this organization. Then we have a third very important field that we always need. That's the issuer about the credential. It gives you the information who issued this entity, and also essentially who is attesting the contents. Because you can only trust the contents of the verifiable credential if you trust the issuer of it. If I get an ID card that comes from the German government, then I can trust that the address is actually proven there. If I get an ID card that is signed by my daughter, then it's most likely not trustable. And then there is some additional option metadata, like ID names, descriptions, validity stuff, credential status, and so on, that can be used for more fine-grained control about the credential. The first three are always mandatory. The other ones depend a little on configuration and on the concrete trust requirements of the data space, but they are important to know and will be used in a lot of contexts. Now, once we have the metadata claim cleared, we obviously need to go to the data itself. In a verifiable credential, we have the claims, usually in a section that is called credential subject. The subject then contains a set of objects with the specific attributes or data pieces that the issuer is attesting about the subject. The subject can, in case of a national ID card, for example, be the user. But it could be also something purely technical. It could be attestations about a data product. It could be attestations about a company, about an organization, or whatever. So you could essentially put everything into this, and the guarantee that it's correct is always relying on your trust to the issuer. The claims itself usually should follow specific data schemes to ensure consistency and interoperability. So only if the verifier and the issuer have the same understanding of date of birth, then it makes sense to use this. Because if I don't understand the same format of the date of birth, then I don't have any kind of interoperability. And the subject itself often contains also IDs that might link the claims to specific holders. So in this case, of an identity credential, it usually always also might link to the concrete identifier of a person. That might help the verifier to confirm that a claim truly applies to the presenting subject. There are other mechanisms to bind a credential to the holder. We will go into this later, but that's one of the options that you have. And then we have the very important proof sections. The proof itself contains details about the digital signature on the credential. A proof always will have a type, which essentially defines the type of the proof, because only with that we know how to validate the proof. If I just get a signature and don't know how to interpret the signature, I cannot verify its validity. We will have a purpose, because there might be different reasons to put a proof on a credential that can be used. This is some more or less the standard mechanisms that we also know from, for example, from the JWT world, to validate proofs on credentials. We will have a verification method that provides us information on how to verify the proof. For example, it could be a link into the issuer's public key set to know which key actually to be used to verify this complete credential. And it might contain the JVS set, which is the actual signature, which ensures the credential has not been tampered with. Especially the later three fields are very much dependent on the type of a credential. So obviously, If I have a type that is not an ED signature, I might have a different way of expressing the signature itself, and I might need additional information to actually validate this this signature. So the concrete contents of the proof always rely on the type being provided here. Now, beyond verifiable credentials, we also have the verifiable presentation. Verifiable presentation is something very important if we talk about exchanging credentials in order to authenticate ourselves. A verifiable presentation is essentially a package of one or more verifiable credentials created by the holder to share specific information with the verifier. So if I have a verifier requesting me for authentication, I go essentially into my wallet, check which verifiable credentials I need to provide him, package them into a verifiable presentation, and send this presentation to the verifier. A presentation can combine multiple credentials, which could be useful when the verifier requires proof of several attributes. If you think again in the real world, if I'm driving around and the police stops me, then they usually will ask for my driver license and also for ownership proof of the car, for example. Then I have to present two of those credentials. Okay, this is my driver's license, and this is my I'm allowed to drive this specific car. So I have to provide multiple credentials for authentication in a single process. This is something that's also very common in data spaces or in any decentralized identity and access management system, and verifiable presentations can be used for that. A verifiable presentation itself is structured essentially the same like a verifiable credential. It also has the metadata that allows us to interpret us. Then it has a list of verifiable credentials, and it also has a proof. So a verifiable presentation, to ensure integrity of the data and to confirm that it actually was generated by the holder that was requested, is signed with the identity of the holder. So the holder itself will also have its private key, sign this presentation, and becomes the issuer of this presentation. He's not the issuer of the credential, but the issuer of the presentation. That also enables the verifier to ensure that a credential is provided by the actual holder. Because, for example, a driver's license, it's very important that only I can use my driver's license. In the real world, we are verifying this with a photo on the identity card. In the digital world, we do ensure this by binding the credential through mechanisms like the subject ID or through CNF mechanisms, binding the credential to the holder itself. And when it's presented, I as a holder now also need to prove that I am actually the holder that it was bound to. I do this by signing my presentation with my key, which is the same key that this ID card was bound to. So that really only in the data space case, for example, that only the user that actually was given the permission or giving the credential as let's say a data analyst is able to use this data analyst credential, and not just give it away to the working student to also use it. Okay, verifiable credentials itself can come in different formats. Right now, there are a couple of them around, but I concentrate on the, let's say, most important one for us. Actually, the one that you have seen as example here are JSON-LD credentials or linked data credentials, because they are very readable. But they are losing some use cases right now. They are coming back for certain use cases, but in our in our data spaces, we rely more on the first two types and formats of credentials here. One is the JWT-VC credential, and the other one is the VC plus SD JWT credential. The JWT-VC credential represents a verifiable credential as a JSON Web Token. I think most of us are well aware of how a JSON Web Token looks like. And it allows essentially to leverage established standard for JSON Web signatures to ensure that the claims are made by the credential and can be validated by the verifier. It also has the benefit that we can reuse a lot of technique that was developed through the last decade, and which is, let's say, well hardened to work with signatures and verify them, so that we actually have the credential that you have seen before, in form of a JWT token. The signature or the proof section essentially moves to the signature section of the JWT token. Part of the metadata moves to the header section of the JWT token. and then we are able to provide verifiable credentials in a very established way and also work with them. An extension to that JWT standard is the VC plus SD JWT credential, which actually sometimes is now referred to as DC plus SD JWT. SD stands for a selective disclosure. That enables a privacy-preserving way of using verifiable credentials by allowing the holder to only disclose specific claims while it maintains the integrity and authenticity of the entire credential. So imagine you have an ID card credential and you go to a web page where you only have to prove that you're above 18. If you use a normal JWT verifiable credential, you have to provide your full identity card. So that means you're not only proving you're above 18, you're also providing your address and your name and whatever is in this credential. With the VC plus SD JWT credential, you're able to only disclose the, let's say, the above 18 claim, and everything else can be kept invisible for the verifier. But due to some specific features of the VC plus SD JWT, the verifier still can validate the integrity of the whole credential. So that's a very interesting feature, and this is also why the VC plus SD JWT is the most important format for the implementation of the UD reference architecture wallet. So members, or let's say inhabitants of the European Union, will have such credential types starting from next year for a lot of their identity features. And then there is a third one that is very widely used, or let's say very well established, which is called MDL, which is a more or less specialized structure for representing mobile driver's licenses. I mentioned here because it's somewhat the first and very much established format of verifiable credentials, which is actually also enforced by, for example, some American member states, states of the United States of America, to actually have mobile driver's licenses. And it also is now becoming more and more important in other parts of the world. Now that we understand what a verifiable credential is, we also need to know what a decentralized identifier is. Decentralized identifiers are essentially a new type of identifiers that enable verifiable self-sovereign digital identities without relying on central authority. That allows the individual to control their own identity and associated data securely and independently. That's important also for our data spaces, that we can control the identity ourselves and independent from a third party, and combine it together with the verifiable credentials to build the trust relationships and the level of sovereignty that we want to have in our data spaces. Decentralized identifiers are also specified by W3C, so by essentially the same body that also the verifiable credentials does, and it defines the syntax of an identifier. It allows the control of the identity to prove the control without requiring the permissions from anyone else. So you don't have to go for a third party to check the identity once you get a decentralized identifier. There is nobody that has to prove for that, or that has to be involved in that. That can all be done completely independently. DIDs are essentially URIs that are associated with the document for this trustable interaction. The document contains stuff like cryptographic material, verification methods, or even services that allow you to prove control about features of or prove control on this decentralized identity. All of this just under control of the holder of the decentralized identifier. Now, how does such identifier look like? Decentralized identifiers, as mentioned, are URIs, and they are structured always in the same way. So you have the DID prefix. The DID prefix just indicates that a given URI is a decentralized identifier. There is not more magic to that. The second part of the DID is more important because it's the method name. The method name itself references a specific DID method. So there are different DIDs, and the DID method defines how to interpret the latter part of the identifier. Because after the method name, there is the method-specific ID. And the method specifies how this method-specific ID is generated, how it can be associated to the DID document itself, how the DID can be resolved to the document, and how the document can be used to verify the authenticity. So might be quite a lot that would be in here. But if you see the examples of the DIDs that I will show you, you will understand better. And after that, there is a section called additional components that might be used to reference into the DID document or to external resources, all again, depending on the method of the DID itself. Now, to have some examples of decentralized identifiers, in the Data Space Connector, we currently support 4 methods: the DID key, the DID JVK, the DID web, and the DID LC. They all look like that. I will give more detail into that. So a DID key is consistent of the DID prefix. Then we have the method name, going to key, and then we have the public key of associated with the DID. And in DID JVK, we have not this cryptic, or we still have a cryptic, but much longer part, which essentially is just a JSON web key. DID web contains essentially an address or a host that can be that is associated with the DID. And DID LC is something even more specific because it uses reuses already established business identifiers, like in this case the VAT number. Now, going into DID key, because that's something very important in for our FIWARE data spaces, we're using it a lot. So a DID key is a method that uses the public key of a public-private key pair as the identifier. It directly incorporates the cryptographic keys into the DID itself. Therefore, it's fully self-contained. You don't need any additional services to resolve a DID key or even provide a DID key. We have a direct key mapping that allows the straightforward verification of the ownership. If I get a credential signed with the private key that is associated to this public key, I can directly identify without any additional involvement that this credential was signed by this by the holder of this DID key, and that's something very important for our decentralized identity mechanisms. A DID key can also be very easily generated because we can reuse standard key creation mechanisms that are also used for decades already. And in the FIWARE Dataspace Connector, it's ideally used for identification of individuals or services, so essentially the holders. If I have a user, we can just assign it the key to them, or it can generate its private key. So we as an organization don't know about its private key, we just know its public key. The same can be done for AI agents or for any other technical services, IoT devices. So they have their own, identity that can be verified without any additional services being involved. Decoding of such DID key is relatively easy. So in this case, the method-specific identifier is base 58 BTC encoded. Base 58 BTC is essentially an alphabet that is reduced about mostly for readability reasons. It's reduced by some characters that can be mistaken from their visuals, and it's prefixed with the multi-code identifier to give the idea to define the key type. In this case, we have set the N as the multi-code identifier, which indicates that we're talking about the B256 key. And now with that, we know how to verify a signature with this public key. The other very important DID type that we have in the FIWARE Dataspace Connector is the DID web. The DID web is designed to be used in web environments. That's also the one, for example, mostly used by Gaia-X, or I think it's still the only one valid for Gaia-X, but I'm not fully sure on that yet. But it provides a way to create identifiers that are resolvable via standard web protocols. The DID document here is available under a well-known path that can be created from the identifier. So I get my method-specific identifier here, and I also have additional parts here. And due to being a DID web, I know how to resolve that to a DID document. The DID document is actually a JSON document that has to be hosted under this host. It has to be provided by a certain set of, it has to be an HTTPS address, and the certificates needs to fulfill certain requirements so that we can really trust it. But it allows us to resolve this DID also independently from any third party. In the FIWARE Dataspace Connector, we usually use this for the organizations itself. So an organization already in most cases has some web infrastructure, can provide such the JSON document, and has the benefits of all the additional features that a JSON can provide that a key cannot provide, because the key obviously cannot be generated into a JSON document beyond its public key. Now, decoding as an example here, we're following the method definition. We know that we have to check the host and then append the well-known DID JSON path. HTTPS is always enforced by DID, as I said, and the additional part would mean that we have to put in a subpath. Now, how does decentralized IAM happen in the FIWARE Data Space Connector? We're back to our initial picture here. Participants in the Data Space Connector are registered in one or multiple global trusted lists. That does not mean much more than we have a list. In this case, the Trusted Issuers Registry API from EPSI, where the DID of each participant is listed. So that's all. We don't have any additional information about them. There is not something registered about users or role. There's just a DID that they are participant. Each participant can access the trusted list and check that somebody connecting it is a trusted participant. So let's say consumer B gets connected by a client from provider B, then it can check, okay, provider B is part of my data space because it's listed in this global trusted list. We can use additional trust lists in order to incorporate public trust providers, for example. We already had the example with the Gaia-X Trust Framework, so we can register Gaia-X as a trust provider so that we then can just say anybody that is a trusted, how is it called, trusted participant? No. That is trusted in the Gaia-X or properly registered in the Gaia-X ecosystem is also considered a trusted participant of our data space. So that's possible. You're not forced to just use one trusted list. You can use essentially indefinite list of trusted lists that you want to use. Now, how does it happen in practice? As mentioned, we are relying on the OID4VC standards here, and you can see back the Data Space Connector architecture that you have seen before. This is now reduced really only to authentication and authorization, because that's all we think about that we are talking about here. We have the provider side on the right. This is a data provider, which has the authentication part and the authorization part, and the consumer organization. The consumer organization does not need a lot. So you usually will have a browser client application. You will have a user that has a wallet where it can hold its verifiable credentials, and the consumer organization needs something to issue credentials to its users. So it needs something where it can define, okay, user A should get a credential. This needs to implement the OID for verifiable credentials issuance standard, because then we can get it into a compliant wallet. And in order to do so, we recommend and deploy as a default in most FIWARE data spaces for consumer organization a key cloak. So key cloak is a well-established identity access management system, and it also supports the OpenID for verifiable credentials issuance protocol, so that we can just use it to get credentials into our wallets. So as a first step in authentication authorization flow in the FIWARE Data Space Connector, our user on the consumer side gets issued a verifiable credential into its wallet. The credential will be stored in this OpenID for verifiable credentials compliant wallet, and now the user can use this credential independently from the consumer organization. So the issuer is not involved anymore, the consumer organization itself also not. Now, when the user tries to access a protected resource, it gets redirected to the authentication protocol portal. We all know this from web applications. If I go somewhere where I'm not logged in already, I get redirected, for example, to the IDP of, we all know those pages where you then can decide, I want to log in with Google, with GitHub, and whatever. Very similar approach happens here. You're trying to get logged in, and then you get redirected to the auth portal. The portal, which is a part of the verifier, provides then a QR code with the connection information for the wallet. If you're talking about a plain user interaction here, let's say the standard case is that our user has the wallets on its mobile phone. It could also have it in the browser or whatever. And then it uses the mobile phone to scan the QR code. The QR code is essentially kind of a link that informs the wallet about the endpoint it requires to start the OpenID for verifiable presentation flow. With that information, the wallet now can connect the verifier itself. It will send some starting information, which includes the service it wants to request and also the scope it wants to use for that. We all know those properties very well from OAuth2 and OIDU Connect. So this uses the exact same mechanisms. And with that information, the verifier requests the credentials configuration from its credentials config service. So this is more on a theoretical level. The verifier has this credential configuration service as part of itself. But the credentials config service is allowed to is used to define which credentials need to be requested for a given service and scope, and it also defines on which trusted list those credentials needs to be registered. So there might be credentials that are important to prove that we have a valid participant of the data space or that the user is an actual user, but there might also be credentials to be requested that that the user has, let's say, as a legal entity in the European Union or stuff like this. So you can define which trusted list that needs to be looked up. So how does the configuration look like? This is the example of the API of the credentials config service, where you can, as I mentioned, define the credentials required for a service and a scope. So we have the scope defined here. Read, for example, target service might have a scope read and a scope write. And we define that in the read scope, we want to have a user identity credential. It should be looked up in the trusted participants list at this address, and also in the trusted issuers list at this address. So it needs to be a participant, but it needs to be also explicitly trusted by myself because, for example, I only allow these participants that pay a fee to me. This is what I can then configure through the credential config service. Now with that information, the verifier requests the concrete credentials at the wallet. This happens through something called the decentralized claims query language, which is part of the OpenID for verifiable presentation protocol. So the verifier sends this query to the wallet. The wallet now checks the credentials stored in the wallet and creates a verifiable presentation. This presentation usually needs to be approved by the user. It's signed with the key of the user. So as mentioned, it's now bound to the user, and it will contain the credentials. Those then are sent back to the verifier as a verifiable presentation. Now the verifier will first have to verify, obviously, the signature of the presentation, so that the presentation is signed by the user. Then it will verify the signatures of the contained credentials and check all the configurations that are defined from the config service. So for all the credentials, it will look up the trusted lists. It will look up that only the claims are included that are allowed by the trusted lists, and then decide about the validity of the presentation. Okay, I already explained that. So we will go to the trusted participants list. We will go to the trust list to check the validity of the credential. And this is how those lists look like. As I mentioned, we are using the AppC Trusted Issuers Registry API, which is implemented in the Data Space Connectors, often through the FIWARE Trusted Issuers List service, which provides this API with the plain storage backend. In the participants list, we only check the inclusion. So that's our Data Space Global Registry, where only the DIDs are listed. And in the issuers list itself, we allow fine-grained control about trusted credentials and claims per user. So per user, we can, per issuer, sorry, not per user, we can define from which time range this is valid. So we could, for example, sell access to a service only for a certain time range. We define which credential type is allowed. And we also can define which claims are allowed to be included. This is a very powerful feature because then you can define, for example, different levels of access to a service. You can define the role, okay, in this case it's reader, but you could define a role like premium reader that gets to the ability to read more data or to read more fine-grained data. And only if you have bought that access, you get an entry into this trusted issuers list with those concrete values to be allowed. Okay, now once the verification is successful, the verifier will send back a JWT token that contains credentials information to the front end. The JWT token itself is now only signed by the verifier. The verifier is so the token that then will be used at the policy enforcement point is not signed by the user or the consumer organization anymore. It's signed by the verifier, and only the signature has to be verified anymore. This is quite important, for example, for performance reasons, because this token then can be used for various requests to the backend, and does not need to verify every credential individually again. So the verifier already is now our trust anchor for internal usage of the JWT token. The verifier provides a well-known JWTs endpoint, like it's also done by existing IDP solutions, and the downstream components then only have to trust this. So the JWT is then in the end provided to the initiating application, and this application can use this to make the requests to the authorization port of the data space connector. At this point, we have solved our authentication. We have a JWT containing the information that we require for our policies and can continue to work. Now, let's go to the authorization part. In this case, now the application uses the JWT token and tries to access the actually provided service. Yeah. In this case, we have the application here, which is not necessarily part of the data space connector, or which is not part of data space connector, but usually made available through the data space connector. So our client application will now try to request this application. And as a first point of contact, it will hit our policy enforcement point, which is an API gateway. We're using API 6, as already mentioned, which also provides a lot of additional API gateway features. But for the authorization part itself, it will first verify the JWT token, that it comes from our verifier and cannot be actually trusted. And with that verifier, with that JWT token, it will forward the request to the policy decision point. So the gateway itself will not do any decision except accepting the JWT token, but it will delegate the decision to our PDP. As PDP, we're using the Open Policy Agent. Open Policy Agent is also well-established open source project, most well-known as being the rule engine in Kubernetes, and we're using it for the evaluation of the policies. The policy enforcement point provides the request metadata, like what host was requested, what protocol was used, what REST primitive was used, and so on, and the authorization information itself and the request body, so that the PDP can make an informed decision on giving access or not. Now, yeah, the PDP itself will then retrieve required information from the policy information point, like the current time, and it will retrieve the actual policies to be evaluated. This happens asynchronously, obviously, but it's integrated into the diagram sequentially for better understanding. Yeah. Now, once the policy decision point, in this case, Open Policy Agent, has evaluated the policy, it will return the decision to the policy enforcement point, and then the policy enforcement point will either forward the request to the target service or deny it, and then respond to the application, serving the data, the application, whatever it is. That's already the magic of authorization in the decentralized IAM of the FIWARE Dataspace Connector. And with that, we have essentially made our application available through the connector. Now, what parts do we have for the authorization? As mentioned, PDP is API 6. We're using the Open Policy Agent as a decision point. Information point is more of a theoretical role because it depends where the information should come from. We have different use cases for that. Time could come from time provider. We have some policies where the information actually comes from the application itself, but that's something more on a theoretical role. And we have the administration point, which is where we use a component called the ODRL PAP. The Open Policy Agent itself does evaluate policies in the format of Rego, so it does not understand ODRL. Therefore, we have a service that that consumes ODRL policies and translates them into Rego so that they can be understood by the Open Policy Agent. Now, what is ODRL? As already said, ODRL is the Open Digital Rights Language, which is a standardized policy expression language used to represent permissions, prohibitions, obligations associated with digital content to enable clear and enforceable rights management. ODRL is, as much of what I showed today, also specified by the W3C, and it allows to define policies on digital content. We are using it to express permissions on the resources that we want to make available. So we are not yet using prohibitions and obligations. We're only using the permissions part of ODRL to define access to the services and data that we offer in our data spaces. There are possibilities to couple them with different resources, so we can use various profiles. I already mentioned the Gaia-X profile. We also have a DOME profile for ODRL included in our ODRL PAP already, and it can be extended to whatever policy parts or policy mechanisms you need for your concrete use case. How does an ODRL policy look like? I'm used the JSON representation here. Similar to our credentials, we again have a context that defines how the policy needs to be interpreted. This is a JSON LD context, so we can redefine parts of it by providing additional contexts. We are actually making use of that and various use cases. But it's very important to understand the contents of the policy itself. Then we have an ID, which gives us a unique identifier of the policy. I think that's pretty clear. And we have a type of the policy or of the ODRL document. Currently, for top-level policies, we mostly support ODRL policy. Actually, this is a little outdated. We now have also support for ODRL agreement and ODRL set. And then we have the actual ODRL permission content. That permission part is what defines our actual rule. This rule here, for example, means DID MyDataProvider.org allows this data consumer to read the resource NGSILD entity 1. That's encoded in this permission, and that's something we can enforce then through the PAP, through the PEP, in order to give a little more information on how this is translated. So we have an assigner. The assigner is the one that gives the permission. So we are the data provider, and we are allowing something to do something. We're defining a target. This in this case is a single entity in NGSILD, and we're assigning this permission to someone. So this entity is now allowed to use this permission, and we're defining which action is actually allowed. In this case, ODRL read. If we're now enforcing this in an HTTP context, we're just saying, okay, this one is allowed to do an HTTP GET on the NGSILD sub-resource entity 1. So that's what the policy decision point will actually make of this ODRL policy. So how do we translate ODRL to Rego? We have the ODRL PAP to provide a CRUD API for ODRL policies, which also translates and stores the policies. The policies itself are provided to OPA through the Bundles API. The Bundles API is standard API supported by the Open Policy Agent, where it asynchronously can get data, methods, and policies from a defined endpoint. Translation from ODRL to Rego is configured through the ODRL PAP. We have a JSON file that connects the policy entries with predefined Rego scripts. So, for example, for our ODRL read, the mapping JSON defines which Rego script it should be used to decide if the read is actually read in the HTTP context. And we have a Rego folder where all the scripts are provided. So the script that defines this ODRL read, and this can be extended and changed on deployment. We have an example here. So ODRL action, ODRL read will map to the Rego method. ODRL action is read, HTTP part. So there are some helper methods also already provided, but those are very specific details that you should take a look at when you're trying to define your policies and when you want to extend the policy mechanisms beyond the existing defaults. We allow namespacing to define different behaviors for ODRL classes in the policies and contexts, and we provide a set of helper methods for commonly used information like the HTTP headers, like the request bodies, or the authorization information provided with the request. Now, policy enforcement itself is happening relatively easy. Every policy itself is condensed into pure, true, and false decision. So there is nothing like maybe it could be accessed. It's always true or false. The policies then combined into single main policies. We also allow grouping by services so that you can define only a set of services to be evaluated on a certain rule. And the open policy evaluates then the main policy or the service policy by evaluating every single policy in the set. Once one of the policies is evaluated to true, the whole policy will be interpreted as true. So once one of the sub policies gives the permission to access the service, then the whole policy set is considered to be true. It's only rejected if none of the policy will evaluate to true. Now I will give an example or maybe two examples of policies that we have. Let's say we want to restrict the accessible targets. We have the example of giving access to a single entity, to a single NGS ILD entity, but obviously we want to have the ability to give more, let's say, access to a broader set at the same time. So let's say we have not only one entity, but we want to give access to a whole set of entities of a certain type. In this case, we say we want to make all the entities of type energy report accessible. We still have a permission and we still have a assigner, so the data provider is still assigning it. And but now we're not defining a single target, but we're defining an asset collection. And an asset collection can be refined. The refinement then contains the information on how to select the assets that are actually accessible. And in this case, we're defining a left operand that is an NGS ILD entity type, and we're saying it needs to be of type energy report. And as long as this is true, we're giving access to any entity of type energy report can be accessed. We also do not assign that now to a single entity or a single ID, but we're saying it's allowed to be accessed by anyone that authenticated in our data space. So that means every employee or every user of a participant in our data space is allowed to see those data. And we say it's allowed to read. Now we also can go further and restrict the access to data based on the role of a user. So that's something I explained before. So we want to give our consumers the sovereignty to define roles or to decide which user should have what access. Now we can put in a policy in place that says that only users with a certain role are allowed to access the data. Therefore, we don't have the assignee now an ID or a very generic rule, but we define a party collection. And similar with the asset collection, we can define now refinements that the party has to, or the user has to fulfill in order to be given access. We are using logical constraints here, so we're saying it needs to fulfill multiple constraints. In this case, we're saying, okay, our user or our requester has to have the role operator, and we also say it needs to be part of the credential operator credential. So only users that provide me an operator credential that contain the role operator are allowed to access my data my data set. And now maybe a last one, because we will then need to go to the next part of the presentation. We could also do some temporal restrictions. We could permit on our permission put a generic constraint. So this is always in use here. And for this, we say the permission should only be accepted or should only be in place from 31/12/23 to end of 24. Then we can say, okay, we put in a constraint. That means, so if nothing is provided here, then it's automatically an end constraint. If my date time is greater than the 12th December of 23, and our date time is lower than the 31st December of 24, then we give the permission. Yeah, that's the examples now for our ODRL. Okay, well, we're through with it now. This is the links. I guess I assume Charles will also circulate slides later. Now we might have 5 minutes left for questions, and then I will hand over to Victor. Any questions? know it was quite a lot. Okay, then I think Victor is here, right? And then he can take over.
Yes, I'm here, Stefan.
Okay, then I will stop sharing, and then it's your turn.
Okay, thank you, Stefan. Let me share the screen. Okay, I think you can now see my screen, and wait 1 second. Okay. So good morning, everyone. My name is Victor Ramperez, and I'm a senior DevOps engineer at SEAMWARE. And I'm going to talk about the deployment of the FIWARE Data Space Connector that Stefan already talked to you about a lot of things of the connector. And now we are going to see how to deploy actually the FIWARE Data Space Connector. So this is the agenda for this part. First of all, we're going to see an overview of the deployment of the FIWARE Data Space Connector. And then we are going to focus on the deployment of the connector depending on the role of your organization in a data space. And, well, more specifically, we are going to see the provider, the consumer, the hybrid of the consumer and the provider role, and the operator role, which is the administrator of the data space or the managers of the data space. And we are going to finish with some recommendations and common issues about the deployment based on our experience. And yeah, this is going only to cover the deployment of the basic data space connector components. There are more advanced features that we are going to cover in the last session. I think it's on Friday. Actually, the documentation, you have here the link, which is actually in the Data Space Connector repository. You have here also the README, but in the document part, you have a specific here in deployment integration roles, and here you have all the documentation about how to deploy the connector based on the role that you are going to have in a data space. And here you have all the documentation. These are the things that we are going to cover now. You have also in the repository, if you go to the deployment section at the bottom. Yeah, here you have this quick start guide. This is going to deploy a local, sorry. Sorry, local deployment in your machine. Here you have the requirements, and this is going to start a cluster and with some, sorry, my voice. And this deploys a local data space in your environment, in your local environment. It's good for educational and training purpose because you are going to be able to see all the flows and all the things, but it needs all the roles because you are going to have a consumer connector and a provider connector, and also some components for the operators of the data space. So it's good for training and educational, but not for deploying or preparing your connector for a production environment. So this is why we prepare also this documentation more focused on how to deploy the connector for production based on the role. And yeah, also I have put here this repository with some deployment examples that I'm going to use in this session and also in the next Friday session. So you can follow also this configuration. Okay, so let's start with the deployment overview. So the FIWARE Dataspace Connector is packaged in a Helm chart, so you can deploy directly using the typical Helm commands. Also, it's more specifically an umbrella Helm chart. So this means that it's a Helm chart that is composed of different dependencies or subcharts. You have also in the repository the charts definition. Here you have the directory. You will see that we have here two Helm charts, the Data Space Connector and the Trust Anchor we are to cover in a little bit later. For Data Space Connector, and as you can see in the chart YAML, it has a lot of dependencies. Okay, so the main point of this presentation is, as you can see here, this is composed of a lot of different components. So you have to have the clear view which components you need to enable based on your role and the specific configuration of the data space. Okay, so you can install, upgrade, whatever you want with the typical Helm commands. Here we are going to see an examples that you will see based on version 10.3.2 of the Data Space Connector. It is the latest version, at least yesterday. Yeah, and the requirements are the typical ones for a Helm chart. So you need a Kubernetes cluster and you need a Helm also. Okay, so let's go into analyze a little bit an overview of the different roles in the FIWARE Data Space Connector. So we have the consumer role, which it retrieves data or services from other participants. So it needs the ability to issue verifiable credentials for its user and also to serve the DID document. So theoretically speaking, it's not necessary to have a FIWARE Data Space Connector if you are going to play a pure consumer role. But it is true that if you need to have something that issue verifiable credentials, we use Keycloak, and to serve the DID, you can take advantage of the FIWARE Data Space Connector to deploy these two components. Then we have the provider, which offers data or services to other participants. So needs to verify incoming credentials and for access policies, host data services that you want to expose through the connector. So the main components that you see with Stefan. That's it. And then we have the hybrid role, which is the consumer and provider. So it acts as both a consumer and a provider, and is the most common scenario in real world data spaces. So your organization is a consumer of some services, but you are also providing some services through the connector. And then we have the special role, which is the operator role. As it says here, it operates the shared infrastructure or trust infrastructure of the data space. So the trust anchor, onboarding services, etc. Some things that we are going to come in on Friday, mainly. And this role is typically fulfilled by a neutral governance body. So it's not a data space participant itself. Okay, so the next thing that we are going to see is for each of these roles, which components are mandatory and which ones are optional. And we are going to analyze some examples, and I'm going to highlight the main things that we know that people sometimes make mistakes configuring and things like that. Okay, so starting with the provider role, the required components of the FIWARE Data Space Connector are the DID. You need something that serves the DID. You need also authentication components, more specifically the verifiable credentials verifier, the credentials config service, and the trusted user list. Here I put this star in the credentials config service because in the new versions of the connector, these components is embedded in the verifier. So you no longer see credentials config service. And we also need the authorization components, mainly the API gateway, the AP6 that Stefan mentioned. We use the official AP6 help chart. So if you have some doubts specific for the configuration, you can go directly to the official documentation and ODRL PAP. Okay, and as optional components, we have the verifier credentials issuer. We use keyclock. Here we have the start because it's true that it's theoretically not necessary, but all the times we deploy the keyclock together with the rest of the components. And the rest of the optional components are the Team Forum APIs and Marketplace. These two components you will see tomorrow, I think, with Francisco. You will cover these two things. The contract management and also some components to support compatibility and integration with EDC and DCP protocols. I think in the last session, also on Friday, Stefan will cover also this part. Okay, so I'm going to show you an example of the provider configuration for a connector for this provider organization. These are the components that we are configuring here. As you can see, it's a very complete example. It includes the required components and also some of the optional ones. We are enabling the marketplace and the TM Forum APIs. And you can see here also an NGSI LD service. This is the service that we are going to expose through the connector. And as a side note, this NGSI LD service, since the connector for the TM Forum APIs already deploys a context broker, a Scorpio context broker, you will see. We just reused that context broker for the service as a demo purpose to be exposed. But in real life, it's not a good idea to expose the context broker that you use for the TM Forum APIs. It's better to have a different context broker or another NGSI LD service. So you have here the link to the repository of examples that I put in the first slide. Is this one? Let me open with editor because I think it's better. I think the font is large enough, but if you cannot see it very well, just let me know and I will try to make it bigger. Okay, so there is a lot of configuration. Most of the things are typical Helm chart configuration for Kubernetes, the ingress and things like that. And since we do not have a lot of time, I'm just going to focus on the main points or the important things. For example, here we are just deploying MongoDB with a Kubernetes operator. It's the MongoDB community operator we use as a dependency. Also, the Helm chart of the connector includes Cert Manager. So we are just enabling Cert Manager for the issuance of certificates. And yeah, just creating a certificate issuer to issue the certificates. Then we have the configuration of the DID. So this is the server that it's serving the ID document. As you can see, we are using here Cert Manager for the provision of the certificates. And also we are using this certificate with a public and private key to be used in the DID document. So this is why we are mounting the volume with a certificate from the Cert Manager. Okay. Then we have the authentication components for the connector. Similar to the MongoDB, here we are just enabling Postgres database. All the components are designed to work with external databases. So if you don't want to deploy your own databases, you can just point to the databases endpoint. But also the chart includes if you want to self-contain everything. Yeah, nothing too fancy here. Then we have the trusted issuer list. Again, just configuring some database configuration with the credentials, etc. Here, the credentials config service, as I mentioned, it's the disabled because it's the new version, which is embedded here in the verifier. But I just keep it here just if some of you already play around with the connector in the past, so you notice this. And then we have the verifier here for the registration. We have the services. This is the typical configuration that previously was in the credentials config service. So here we are creating a service with ID equal to the DID of the organization, and with a scope of OpenID layer credential. And here we are configuring the credentials. In this case, it's a legal person credential, and we have the trusted participants lists of the data space to be checked for the issuance of these credentials, and the trusted issuer list, so the trusted list local to this organization. And we have here the presentation definition, and we have a different service for the, in this case, the service that we want to expose, this NGSILD service. And here we are using a different type of credential. In this case, it's an operator credential, and just pointing to the same participants registry of the data space and the same trusted user list here, and some presentation definition. And what the rest is typical Kubernetes configuration for the ingress. And yeah, an important thing here is that this verifier needs a key to sign the tokens. And at the moment, there is a limitation because the AP6, which is the one that is going to receive these tokens, cannot use elliptic curves. So this is why we are using here RSA in this case. So we are issuing a certificate to have this RSA key that we mount here in the verifier. Again, to emit this key, we use Third Manager. Okay. And the rest is just Kubernetes configuration. So about how we use this key, or how we issue this certificate, if you go at the end of the configuration, we usually put at the end, but the Helm chart of the connector includes this extra manifest here field, in which you can basically put whatever manifest and it's going to apply. So here we are creating this certificate, which is the one that we configure in the verifier. So here we just declare the manifest for the certificate and just mount it in the verifier. Okay, let's go back. Just a bit, yeah. Okay, this is the verifier. Okay, then we have the authorization components. As I mentioned, we have the AP6. So this is the official Helm chart of AP6, so the common configuration here. And the most relevant things here is the configuration of the routes in AP6. So here we are configuring two routes for this data service that we want to expose, this NGSILD. We have this route for everything, basically. And as you can see, the upstream node is this Scorpio, which is the context broker. And we have two plugins for this route. We have the OpenID Connect plugin that is going to validate, to authenticate the request to the verifier. And we also have the plugin for OPA for managing the policies. Okay, and we have an extra route here also for this service for the OpenID configuration. So in this case, we only have this service, so we only have these routes. But if you want to expose more services, you will need to create more routes here in AP6. Then we have the ODRL pub. Nothing too interesting here. The Scorpio, which is the context broker for the TM Forum APIs, and in this case, also the service that we want to expose as an example. TM Forum APIs configuration. You will see that tomorrow more in detail with Francisco. And yeah, and the marketplace. Also, this is going to be covered tomorrow. But basically, you have the marketplace is composed also for different subcharts. You have the charging backend, this ecosystem APIs, and the logic proxy. Okay, so basically, in the marketplace, you need to configure the endpoints of the TM Forum APIs here, as you can see. Yeah, then we have the contract management component. I think also Fran is going to cover this tomorrow, but the configuration is not really difficult. And we have Keycloak here. I'm going to cover Keycloak in a different step later, because it's something common for a lot of roles. So I'm going to keep it here or later. We have also a dashboard to manage the connector. Here is disabled, but in the Friday session, we are going to see how to configure the dashboard and the things that you can do. But basically, it allows you to manage through a web application the policies in your connector, the services, the trusted issuer list. If integration with monitoring is enabled, you can see some Grafana dashboards and some telemetry there. And the final thing that we have is this extra manifest in which you can apply other manifests. And apart from the certificate and one secret here for some CAs, we have here created this ingress. And this ingress is for the service that we are exposing. Okay, the routes that we put in the AP6. So we are creating here the Kubernetes ingress in this part. And this is because there is a limitation in the AP6 Helm chart to create that. It does not allow you to configure some of the parameters in the ingress. So this is why we prefer to put directly here. You can apply separately, but with this extra manifest, you can include everything here. And the rest is the rest of the components that are disabled here. Okay, so I'm going back to the slides. Okay, from changing the role to a consumer, as I mentioned, the only required components is a verifier credentials issuer, the Keycloak, and you need something that serves the DID. It's not theoretically necessary a connector, but since we have it, the connector can deploy these two required components. You can take advantage and just use the connector and only enable these two components. And there is other optional component, which is for the compatibility with EDC and DSP. And yeah, we have another configuration example. I will open in the editor. It's much easier than the provider. We have Keycloak that we are going to see right now in a second. And we only have also enabling the DID document here. So it's very basic for the consumer. Okay, so about the Keycloak, as I mentioned, is something that it's common for most of the roles. So the complex part of configuration of Keycloak, it's the Realm configuration, because the rest is, again, Kubernetes stuff. And yeah, the things that we need to configure are the client roles, and the credential types in the client scopes. So the claims and attribute mappings. Before going to the configuration in detail, some important things. Yeah, the organization's DID private key must be the one used by Keycloak for signing the verifier credentials. So this is a common issue that we saw in the past with some of the people using the FIWARE Dataspace Connector, that they put a private key in the DID and a different key in the Keycloak to sign the verifier credentials. And this is not going to work. You need to have the same key in the DID and to sign verifier credentials, because you are going to sign the verifier credentials, and then in the verifier is going to check the signature of these verifier credentials and compare to the with the DID public key, and you need to work too much. Okay, also you will see an init container that it is just creating the key store. So we need to just transform the key format to PKCS12. So that's it, nothing else. It's not creating anything, it's just transforming the format. In the current version of the FIWARE Data Space Connector, in the key clock image, you will see that it is a SEAMWARE image, but this image is only an image built based on the main branch of the official key clock repository. And this is because the latest version of the key clock, they had a bug with the QR generation, and they didn't include the bug fix in the latest release. So we just, since this bug fix is in main branch, we just compile and create that image that includes the fix, so nothing else. Also in the future with the next release that includes some UI upgrades, our plan is to come back again with the official key clock image. And related to the wallets, you have also some documentation in the repository about the compatibility with this version of with the latest version of the FIWARE Data Space Connector. We have tested the compatibility of Lizzy Wallet, at least for these versions in iOS and Android. You will see in the Helm chart that we have prepared the key clock configuration with a flag, so you can directly configure, okay, I want to include in my key clock the ability to be compatible with these wallets, so you don't have to manually fine-tune everything, let's say. And also, we use EUD wallet mainly for debugging purpose, because with EUD wallet you can retrieve logs. So we recommend you to use EUD wallet for that purpose, because in Lizzy you don't have any logs. It's not merged, but hopefully at the end of today you will see an extra row here with the Android version. So you can directly download the APK or compile yourself with the different repositories. Okay, so let's go into check some key clock configuration. Let me find the key clock. Okay, here. So yeah, the first part is the typical Helm chart configuration. So yeah, the admin user, the existing secret, blah, blah, blah. The ingress configuration, database. Yeah, you can see here that we are mounting this secret, which is the certificate for the DID. So they are sharing the same secret, the DID and the key clock here, because of this that I mentioned, that they need to have the same private key here. This is the init container, yeah, this one that transformed the format for the key store. And then we have here this realm block, which is actually a wrapper you can see in the templates for the creation of the realm. Okay. So here we have this, for example, wallets, these issue credentials to users. So if you enable this, all the users that you have in the realm are going to have the ability to issue the verifiable credentials. If you don't enable this, you need to manually issue the credentials that you want for each user. Then we have the different client roles. Here we are creating one for the DID of our organization, the consumer one, and another one for this target, which is in this case, the provider. Okay, and we are creating a customer role and an admin role, and we have also an operator role for this other target. And then we have the users, in this case, just an employee user with credentials, and we are assigning here the client roles for this user. For example, for our organization, it's going to have the customer role. For the provider, target the operator, and these are the Keycloak roles for view profile and manage account. And then here we have the definition of the clients, one for the DID of our organization, the other one for the provider. And yeah, here we are defining the verifier credential. So we have this legal person credential and one operator credential here. So we are just defining the format. This is the new format for the selective disclosure. In this case, it's the legal person credential. And yeah, and then we have these protocol mappers here that we are, for example, here saying, okay, the user attribute in Keycloak of email, we want to map the claim name attribute email, for example. So here we are defining all of this. These kind of things in previous versions of Keycloak are not possible to see or manage through the UI. So the only way is through the Realm configuration. But in the current and next versions, it will be possible to manage all of this from the UI. And similar to this, we have also the configuration for an operator credential here. And the final part here is the signing key. And it's just, we are configuring the key that we transform, but basically it's the same key as the DID, because this is the one that identifies our organization. Okay, so this is the main configuration for Keycloak. Also in the repository, in the documentation, you have a specific part also for Keycloak. I think it's here, yeah. So you have a specific documentation for all the things that you need to configure for Keycloak. And some considerations, because there are some breaking changes between the connector version 9 and 10 due to the upgrade on Keycloak. Okay, then the next role, it's the hybrid one. So your organization is a consumer and a provider in a data space. So the required components is the union of the consumer and the provider roles, as you can imagine. So yeah, basically the same as the provider, and as optional components, the optional components for the provider. I have included also a configuration example in the repository, so if you want to take a look, but basically it's 90% equal to the provider one. And yeah, and then we have this operator role, which, as I mentioned, is not a participant in the data space, but is the entity that manages the common infrastructure of the data space. So the only required component, let's say, is the trusted user registry, the trust anchor. It's the global participants leads in the data space. And for that, we have also a Helm chart, and it is on the same repository as the connector. In the charts, as I mentioned, you have the Data Space Connector and also the Trust Anchor Helm chart here. It's really basic. It only has two dependencies, as you can see, and one of them is the database. So if you use an external one, you can disable the included database there. And some other optional components of this operator role, which are the central marketplace, central verifier credentials issuer, the onboarding portal, this infrastructure that it is optional and common for the data space. These are the things that we are going to cover in the on Friday's session. And yeah, I have also an example for this operator. Let me see. Here, today we are going to see the Trust Anchor, which is very basic, and the other ones we are going to cover on Friday. Yeah, so basically it's the configuration of in this case, Postgres database, and then the only thing is the trusted issuer list with the ingress configuration. So really, really simple in this case. More advanced and complex things with this other, the central marketplace or the onboarding portal. But for today, let's keep this part simple at least. Yeah, as a sum up, here you have this component matrix. So basically, this is listing all the components that you can deploy with the connector, and you can enable and disable all of them. And yeah, we put here for the different roles for each component, if it is required or if it is optional. So it's a cheat sheet, so you have here. This is extracted from the official documentation, but it sums up what we saw in this last part of the training. Yeah, and some recommendations and common issues to based on our experience. So prefer the ID web type over the ID key for organizations and real environments. Basically, with the ID web, it's much easier if you update the keys and the documents, because you have this extra layer that you don't have in the DID key. Yeah, what I mentioned about the DID private key that must be shared with the key clock to sign the verifier credentials. The limitation of the the signature in the verifier that must be RSA, because AP6 does not support elliptic curve. Yesterday, checking the issue, I saw some activity, but to be honest, I didn't have time to check if it is actually solved or just closed. I need to take a closer look, and if this restriction is not anymore true, we will update the connector. Yeah, the other limitation in AP6 for the creation of the ingress. So remember that you can use the extra manifest in the FIWARE Data Space Connector to apply these kind of things. We recommend to use the Third Manager for ingress TLS certificates and other internal signing certificates as the one in the verifier. So this is why we include Third Manager as a dependency in the connector. So it is much easier if you enable Third Manager directly. One thing here about TM Forum APIs, there are two versions. You have the standalone API for each of the APIs, and you have an all-in-one, which is just one pod that includes all the APIs. You will see that tomorrow with Fran, but for the deployment for resource-constrained environments, our recommendation is to go with the all-in-one. You will see in the local deployment that I mentioned that we use always the all-in-one for this reason. And also based in our experience with the users, it's better to plan and design the deployment carefully to save time. Things like, okay, the verifier credential types that we want to use in our data space, the roles, which optional components we are going to deploy in our data space, or which optional components are available in the data space that I'm going to connect, self-hosted databases versus external ones, these kind of things, because we saw in the past that if you don't take these decisions in advance and just jump into start deploying things, it's much difficult, and you will save time if you previously design these things and not deploying everything and then try to upgrade, change things. It's much more complex. Yeah, about Bitnami health charts, as you can see, we have a lot of dependencies, but we had a lot of work to avoid the Bitnami health charts, and right now the only one is the AP6 etcd, if you enable etcd, of course, which is a dependency in the AP6. So it's not a dependency that we can control, let's say. do not use, you will see that in the chart you have this generate passwords that generates the passwords and the credentials. It's not recommended for production. It's put in the documentation, but just in case. For production, just follow the best practices for Kubernetes and use sealed secrets, external secrets, and things like that. So for you to not to update to your repository the credentials in clear text. Use wildcard certificates with caution. Basically, if you use, if you have more than one organization or DID, if you have only one wildcard certificate for all of them, it's not going to identify clearly which organization. And also related to the marketplace that you will see tomorrow, but this affects the deployment. There is a matrix of compatibility of the different components of the marketplace. So just take into account this matrix. Just don't put one version here and another version which is not compatible for the other component. You will always have this matrix of the latest versions compatibility, but Francisco is going to cover this tomorrow more in detail about the marketplace, the Inform APIs, and these things that I mentioned that Stefan didn't cover today. So yeah, I think that's everything. Here's some links and resources that can be useful, and I will share also the slides together with Stefan. And now, if you have any questions, yeah, please feel free. If not, I don't know, Stefan, if you want to add something else, or if you just finish.
No, nothing from my side. So.
If there are no more questions, then I would like to take this opportunity to thank Stefan and Victor for their contributions today. Thank you for attending, and we hope to see you at the next session. Bye-bye.